Guys, normally we start this unit with circles because it's an easy day to get back into this kind of stuff, and then we go to parabolas. But because I'm going to be gone, we're going to do parabolas today because I'm here. And then you're going to watch a video Wednesday reviewing circles. It's like 24 minutes and you'll probably fall asleep, and then you can work the rest of the day, okay? Tomorrow you're going to watch day 2 on parabolas, and that's going to be an important one to pay close attention, okay? It's last year's video, so when you play the video tomorrow, it's going to refer to the reference sheet, and I think it's going to say pink, but ours is green for this section, okay? I didn't re-record the video. I watched it and I was like, yeah, it's good enough. You can watch this. All right, so our reference sheet for this unit is green, and you are going to be able to use your trig one still for this quiz because there's stuff on the quiz that still refers to the trig stuff. All right, so you did parabolas. Matter of fact, we did parabolas at the beginning of this year. We had things that looked like this. Just kidding. Does that look familiar? Let me turn that stupid sound off. What in the world is that? Okay. Vertex form, yes? Okay. We're going to move into what are called conics. Here's our learning targets. You need to be able to graph a parabola, finding the vertex, which you already know how to do. But now we're going to talk about focus and directrix. Axis of symmetry we're familiar with in that it's the line that goes through the vertex right down the middle, right? All right. You're going to have to complete the square to put an equation in standard conic form, which they call standard form, I think. And to be able to write an equation given a whole bunch of different situations. All right, when I use the term conic sections for chapter 7, this is because when you do this double cone thing, it's called a double napped right cone. Okay, you can cut parallel to one of the bases and you get a circle. Does everybody see that? If you cut at a slight angle, you get an oval, which we're going to do as soon as I'm back, ellipses. Okay. If you cut parallel to one of these slants here, you get a parabola. If you cut straight up and down, perpendicular to the base here, you get 2 U-shaped things called hyperbolas, and those we will do not for a couple weeks because next week is a short week again. For you guys? Did you know that? You get off. I have a SIP day the 9th of March or something. All right. There are also conics that include point line and intersecting lines. These are called degenerate conics, and yeah, they're just so degenerate, we're not going to do them. Okay. We're going to talk more about locus of points. A locus of points is the set of all points that meet something, meet a criteria. Let me do a real quick example. If I ask you, what is formed by all the points 3 centimeters away from the end of my finger? Every point that's 3 centimeters away from the tip of my finger, if I could color them all red, I'd get a what? It should actually be a sphere if it wasn't in a plane, right? If everything a certain distance away from the end of my finger, does that make sense? It would make a ball, a sphere, right? If I said everything on this paper right here, 2 centimeters away from that dot, that would be a circle whose radius would be 2 centimeters. We get a little better idea. Okay. The thing for a parabola is it satisfies the condition if I have a line and a certain point here. For example, this is my house and this is Highway 173, we'll say. Okay? And I want all the points that are the same distance from my house as they are from the highway. How do you measure the distance to a line? If I wanted to measure from here to the line, I'd have to measure it perpendicular, right? I can't just decide, oh, I'm going to measure over here. Okay, so that's how far it is away. If these distances are equal, okay, Or I go over here and I say this distance is equal to this distance. Or I go up here and I say this distance is equal to this distance. All of those points, which would obviously include this point, right? Smack dab in the middle. All of these points would make a parabola. Yeah, we need the big dot theorem really badly. Okay? Supposed to be hitting all those. But all of the points on a parabola, the locus, the definition is, are equidistant from, what is this point called right here? That's the vertex. Okay? But all the points on a parabola are equidistant from this point, which is called the focus, and this line, which is called the directrix. How many of you have at least heard that vocabulary last year? Okay. Some of you haven't, because if you didn't take honors algebra 2, I don't think you've done it. So there's this magical point called the focus and a line called the directrix. Exactly in between those is going to be the vertex. And then the parabola is all of the points that would be equidistant from those two things. Now, this distance has a special name. This distance conceptually is P. It's the same distance, okay? From the focus, I shouldn't have an H there, to the vertex, to the directrix. This is P, the distance P. So our new formula for a parabola, if you look on your green sheet now, one that opens up like this one, it lists like this. Everybody see that formula at the top of the parabola one that's opening up and down? Okay. If I rearranged this so that it was in vertex form, everybody paying attention up here? I would take this and divide it over to this side, so I'd have 1 over 4p. And then I'd add the k over to this side. And that would be y equals, I'm going to move the y over here. Does this vertex form? Except we just called this a for the stretch, right? So the stretch is 1 over 4p. And p is the distance between these. P, that distance p, also determines how wide or narrow the parabola is. All right, I just covered a whole bunch of this. This is the form we're going to use that's on your sheet. This is on the top of your notes. It says this, okay? If I divide and rearrange it, I get vertex form. But look on this sheet. What else is on the green sheet? Next to it, there's a whole nother box where the parabolas go sideways, okay? We're going to do sideways parabolas today, and they're going to be solved for x, or the y is going to be the squared quantity. All right, so off your reference sheet, it's exactly what it looks like, and you get to use this. So it gives you all the little recipes. That's what I call them, okay? The recipes for all the things you have to find. So this example says x minus 3 equals 12, y plus 4. Identify the focus, vertex, axis of symmetry, directrix, and graph. Well, apparently I just decided to give you the graph here, and it may be all worked out on your paper, but I'm going to go over it real quick. What I would do is I would look at my sheet, and I would write right next to it the formula off my sheet. Right? Oh, it's minus k. Is that the formula right off the green sheet? All right. So now, what is this telling me? H is right there. H is 3. 4p is equal to 12. So p is 3 if I divide by 4. And right here, be careful, what's k? K equals -4. So now, vertex, what's the recipe on the sheet for vertex? just HK. So what's the vertex of this parabola? 3, negative 4. The focus, what's the formula? It says H, comma, K plus P. Everybody good? See where I'm getting that off the sheet? So the focus is 3, comma, negative 4 plus 3, which would be negative 1. Yes? Okay. Axis of symmetry, it says is X equals H. What's H again? 3. And the directrix, it says is Y equals K minus P, which is negative 4 minus 3, or Y equals negative 7. Okay. I wouldn't have done any of that. I would have used the concept. I would have said, okay, the vertex is at HK, 3, negative 4, down here. P is 3. The X is squared, so that means it opens up or down. Okay, because we're used to X squared parabolas, yes? Okay. If P is 3, it means I go 3 units this way and 3 units this way to find the directrix and the focus. This has a positive P, so it opens up. This is the vertex, so this one's the focus, and this is the directrix down here through this line, or through this point, 3 units below this. So that puts this at Y equals negative 7, and this ordered pair at 3, negative 1, without using any little recipes, okay? The thing that makes this a little difficult is you have to be able to graph this and show me how wide or narrow it is. So you need to put another value in, okay? We can put in, look back at this equation, we could put in an X or a Y. Any ideas what we could put in to this equation? You don't want to put in the X from the vertex. It's got to be a couple points away from the vertex. So what do you want to try? I'm going to suggest we put in an X because then we're going to square it and the squared's going to go away. If we put in a Y value, then we'd have to square root something later. Anybody pick an X, please? 1. If I put in 1. Okay. What do I get over here? 1 minus 3 is negative 2. Squared becomes 4. I'm going to divide the 12 right away. Okay. Now, if I subtract 4, what's that going to be? What's 4/12 minus 4? A decimal's fine. 4/12 minus 4, guys. Negative 3.6 repeating, right? So at 1, this parabola is still down almost to negative 4. All you need is one ordered pair to show me, is this puppy wide or narrow, okay? This is pretty wide. It's pretty flat. All right, so we went through this question. We are going to try number 1 together. Ready? Okay. What do you know about this? What's happening? Right away, the Y is squared. It's going to go sideways. I'm going to write the formula underneath. Can you find the formula on the top of your green sheet? What am I going to write under here? Y minus K squared equals 4P X minus H. All right. Hunter, tell me one thing. What's H, what's K, what's P? You pick. Yes, good job. Sam, tell me one thing. Either one. I don't care. H is 3. Okay. Other Sam, can you tell me P? Okay, because A equals 4P right here. So P equals 2. All right. So the vertex, everybody, HK. 3, negative 1. 3, negative 1. Oh, this is nice graph paper. I'm going to warn you, in this whole unit, there's crazy graph paper again where it counts by 2s and jazz, okay? So watch out for that. It has a P of +2, and you already told me this is going to open sideways. Anybody know which way it's going to open then? If it's a positive P, can you see that on your sheet? Underneath the graph, it says P is greater than 0. Do you see it? Opens to the right. It's going to open this way somehow. I'm just going to do that so I know, okay? You could write it here too. What else can you tell me? Focus? Okay. Conceptually, guys, I hate using recipes, but they're there. But the distance is 2 tells me what? Okay, the parabola always opens away from the directrix, and the focus is always inside the concavity of the parabola. Does that make sense? So if it's opening to the right, 2 units, P is 2, so 2 units inside here is the focus, and 2 units back this way is the directrix. Now, let's use the formulas so that everybody's comfortable they could do it. It says for the focus, H plus P comma K. So what would that mean? 5, when I put in 3 plus 2, comma, -1. Is that where we found it? Yes, 1, 2, 3, 4, 5, -1 is right here, right? That's the focus. The directrix, according to the sheet, says it's a vertical line x equals h minus p, which is 3 minus 2, so x equals 1. Is that where we drew it? Okay. And what did I skip? Axis of symmetry is old stuff. Axis of symmetry is the line right through the middle. The axis of symmetry should be y equals 1, I'm thinking, but the sheet here says y equals k. Should be -1. Yeah, I wasn't looking carefully. Okay, this is the only hard part. Figuring out another point. Looking up here, okay, the squared is the y, so I would prefer to put in a y value. What is a y value a couple units off of the vertex? Y equals 4 would be way up here. Okay, y equals 0 would just be 1 unit off of the vertex here. Y equals 1, where it's going to cross this line. If we put in a 1 for y, the vertex was at 3, -1. So if we change the y value a couple, right, we could put in a negative, add 2 to this, and we get +1 or more. You could go further. You could even use 0, like Kendra said, okay? But if I put in a y equals 1, I'll have 1 plus 1 squared equals 8, x minus 3. I don't care if it's ugly, I just want an estimate. 1 plus 1 is 2, squared is what? Now, I could distribute over here, but can I just divide by the 8, guys? So I get 1/2. So I get 3.5. Did I go too fast? So when I put in a 1, I got 3.5. So 3.5, comma 1. There's an repair. Could we find another one right away then? There's symmetry, right? So now I have 3 points to show that my parabola is fairly flat or open or whatever you want to say. It's not narrow, right? All right, and I know it's tricky. Where did you get to the value? Well, and some of these you could type in your calculator, but is this one going to be nice to put in your calculator? It's hard to get the y by itself, right? All right. Which way is this one going to open? You know what? Just get started on your own. Write the equation underneath and find h, p, and k for me. All right, what's h, guys? Negative 2, k, positive 1. So the vertex is at negative 2, 1. P is 4p equals 4. So P is 1. Okay, if P is positive and it has an x squared, according to our sheet, it opens up. Does everybody get that? The x was in the squared one, right? So it's got to open up or down. The P is positive, so it opens up. All right. The focus, it says, well, conceptually, it's 1 unit inside, right? It's 1 unit inside this. Oh, I hate this graph paper. Negative 2, 1 is here, isn't it? Okay, and it's supposed to be opening up. 1 unit inside of that parabola would be here. Did I do it right? Okay, thanks, because, yeah. All right, the focus, it says, is H. See, I never use these formulas, so I have to look at the sheet. H, comma, K plus P, which would be negative 2, comma, 1 plus 1, which is negative 2, 2, which is where I put my little focus right here. All right, directrix is 1 unit the other way. It says y equals k minus p, which is y equals what? 1 minus 1 or 0? Okay, I'm going to graph that in red so you can see it here. It's this. Okay, that's the directrix. Does it need to be an equation, guys? It's a line, not a point. It's got to be a y equals, x equals, depending which way it's going, okay? And the axis of symmetry, it says it's just x equals h. So what's h? Negative 2. So there's our symmetry right here. X equals negative 2. Y equals 0. Okay. What do we want to put in up here? This is the hard part, and I know it. Look up here. I want to put in an x value, right? Because it's what's squared. Negative 4, is that a couple units away from? Sure. We can put in x equals negative 4. You could put in something further if you want. If I put in a negative 4 plus 2 quantity squared equals 4 times y minus 1. Okay. Negative 2 plus 2. Anybody? Negative 4 plus 2. I think I said that wrong, didn't I? Negative 2 squared is 4. If I divide the 4 over to this side, it'll say y minus 1. So what do I get? 1 plus this 1 is 2. Skipping steps here. So what's the ordered pair we just found? Negative 4, positive 2, which is right there because of the weird graph paper. Doesn't give me much to go by. Okay, I could have gone all the way out to positive 4 and found a point if we wanted to see more, because the graph paper counts by 2s, but you get the idea. What I don't want you to do is just slap something on that's really narrow or really wide, okay? I want you to find, okay, do we need to do one more? All right, I'm going to go super fast, though, because we got a lot to do today. This would be y minus k quantity squared equals 4px minus h. So I'd get k is 3, h is 6, 4p is 2. What does that make p, guys? Okay. This one has a y squared, so it opens sideways. The p is positive, so it opens which way? Opens to the right. So conceptually, if I go over 6 and up 3, and I put the vertex, it's going to open to the right, and p is only half a unit away, inside there, and back here. Anybody getting the idea? The smaller the P, the what? Narrower or wider? Can you tell? The P makes the stretch smaller. What did a smaller stretch do? Do you remember? Let's see. Let's see what happens. Okay. If we put all this garbage into the equation, the vertex is where? 6, 3. The focus, H plus P, comma K. What's H plus P, guys? 6 plus a half. I'm going to be lazy and do a decimal, okay? Because it's exact. You're welcome to make it an improper fraction or even a mixed number. Comma K, which is 3. So if this line is 6, 6.5, 3 is right up here, just barely inside. The directrix, it says is X equals H minus P. What is that? Can I be lazy and put 5.5? Okay. 11 halves, I think, if you wanted it. Fraction. As long as it's exact, I don't care if it's a fraction or mixed number or... All right. Axis of symmetry. Y equals 3. So it's this purple line going right through the middle. Whoa! That's a little bit better. Neither side is good. All right. I need it to have one ordered pair. We're going to put in an X or a Y. Because of what's squared here, we want to put in a Y. The Y was 3 from the X's, so you want to put in like 5. 5 minus 3 squared equals 2x minus 6. Okay, 5 minus 3 is 2 squared is 4. If we divide by that 2, we get 2. X equals 8. So what did we put in? We got out X is 8 when we put in a 5. So 8, 5. That's not even close to 5. Eight, this is 2, 4, 5 would be right up in there, right? Oh, this one's looking a little what? Narrower. Notice if you went this way, it was down. We're counting by 2s, so 2. I think it would be at 8, 1, but it's got symmetry around that purple line and through the middle. All right, so the smaller the P, the narrower. Okay, the smaller the P, the narrower. All right. I'm going to skip this one. Is that okay? Which way would this one open? This would open down because it's got an x squared and a negative. Okay. Anybody know what P would be? Oh, they're just evil. Is this even the right form? On my sheet, it says x minus h squared equals 4p y minus 6. So what do we need to do? Multiply the 12 over to that side, right? The negative 12. If I multiply this side by negative 12, everybody okay? I'll just have 1 there. It means I got to multiply this side by negative 12, so it would look like this. So it does open down, but P is negative 3, so it actually would be really wide, I think. Okay. All right. Now we're going to write some equations. It says specific characteristics to use to write an equation. So this one says write an equation for a parabola with a focus here and a vertex here. As soon as they give us the vertex, what do we know? H and K. So H, according to the vertex here, is 1, and K is -3. All right. Then we need to figure out what P is. Look at your sheet. If we know the vertex is at 1, -3, right here, and the focus is at -4, -3, wow. Some of you can just figure out that distance, that's P. Conceptually, okay? How far apart are those? 5 units, right? And it's opening to the left, so it's -5. Some of you are totally clueless what I just did. All right? Go to your sheet. If it's opening left, what's the general formula say at the top of the sheet right there? It opens to the left. All right, some of you aren't even going to know what it opens. How about look here? Which one has a vertex and focus with the same Y value? See that? That's K, right? So it's got to open left or right. Do you see what I'm talking about on the green sheet? Okay. Now it says the focus is H plus P. Well, what is the focus for the comma K? Well, I already know K is -3. But on this focus right here, this is -4, and I know H is 1. So 1 plus P gave me a -4. What does that make P? -5. Does that work? I'm trying to show you that you can use the sheet or you can use the concepts of what you know about a parabola. All right, so how do we write this equation? Go back up to the top. It says y minus k. What was k? -3, so I should probably write y plus 3 squared equals 4p. Okay, p was -5, so I still have to put a -20 in there. And then x minus h, which is 1. All right, let's try this one. The focus is at -1, 5. Hate this graph paper in case I haven't said that in the last 2 minutes. And the vertex is at +2, 5. Okay, this is the focus, this is a vertex. What can you tell me? It opens left. Okay? I don't know how wide or narrow it is, but it opens left. Because the focus is always inside the concavity. Everybody good? Okay. What else can you tell me? H is 2, K is 5. Anybody tell me what P is already? Okay. The distance between those is really P, and it is 3, and it's opening to the left, so P is going to be -3. But let's pretend we had no idea. We went to the sheet. We said, oh, they have the same K value, so that means H plus P, comma K, is where the vertex is, or the focus. So I have -1 equals P, or H, which is 2 plus P. If I subtract 2, I get, is that what you just told me, that P was -3? Okay, let me pause 1 second. All right, guys. So do we know everything to write the equation already? I feel like we do. If it's open and sideways, the general form is y minus k squared equals 4p x minus h. Somebody pluck some numbers in there for me. Y minus 5 squared equals 4p, -12, x minus h. Boom. How we doing? Okay. What do we know right away on 7? Okay. It says opens down, so I know its general form is this. What else do I know? So h is 5 and k is 3, right? The vertex is always just hk. Okay, I like to draw the sketch because it helps me conceptually understand what's going on. If I went to the right 5 and up 3, what kind of line is y equals 6? Horizontal line right up there. Can some of you tell me what P is just looking at it? How far is it away from that vertex point of 5, 3? It's 3 units up, right? But, okay, you don't have to know that. You can look at the little sheet and go, oh, the directrix is y equals k minus p. Well, I know that 6 is where it is, and I know that k was 3. So if I subtract, I get this, which I divide and get p is -3. Does that fit with the information we have over here that it should be opening down away from the directrix? Okay? So somebody write the equation. X minus 5 quantity squared equals -12 times y minus 3. Oh, no, thank you. I did that on something earlier and totally confused myself. Yeah, only one side is squared. When we have squareds on both x's and y's, we either get a circle, an ellipse, or hyperbola. So, different world. All right. Oh, focus and directrix. A little bit juicier. Focus and directrix. Okay, opens right. So right away, I know it's y minus k quantity squared. That's supposed to be a squared, sorry. Equals 4p x minus h. Okay. What's the general form for the focus on one of those? H plus p comma k. So what do I know right away? K is 1. Okay. And h plus p is 1.5. All right. The directrix equation is what? X equals h minus p. So h minus p equals 0.5. Now, you can figure out that it's right smack in the middle of those. What's halfway between 1.5 and 0.5? 1, right? Could you also, if you couldn't figure that out, look at what we have here. Is this a little baby system? Remember at the end of last semester? Or substitution, or just can I add them together? 2h equals 2, h equals 1, yes? Oh, wait, I already know h. No, I wanted both h and p. So what's p have to be? If I put that back in there, I get 1 plus p equals 1.5, so p is 0.5. Okay, can you write the equation now? Y minus, what was k? 1 squared equals 4p. What's 4 times 1/2? 2 x minus h, which is 1. Okay, let's graph this. The vertex is at 1, 1. P is 0.5. Which way does this open? To the right. So the vertex, or the focus is 0.5 this way. The directrix is 0.5 this way. Okay, which would I want to put in if I had to find another point? I just want to practice that idea one more time. Which would I put in? I want to put in a y. And like 3 would work, yes? So if I put in a 3 there, what's 3 minus 1? 2 squared is, okay, solve that. If I divide by 2, That's -1. I get x equals 3. So we put in a 3, got out a 3, didn't we? We put in a 3 for y, got out a 3 for x. So this baby goes through 3, 3. So it's kind of narrow compared to some of them we've been doing. All right. This is the assignment. Okay. Tomorrow you're going to watch a video, and there's some tricky stuff on there. If one of you would run the video and pause it when you need to, that would be good, okay? Do you know what I'm saying? Somebody else can sit up here and just take their notes off of my screen. Or you can just say, stop, and Miss Jones can pause it, okay? But do you know what I'm saying? If it's going too fast, okay?